Hey, Hassan, yet another episode of what are we going to talk about? If I understood right from a brief conversation, you're going to explain the real world use case of Inception. Have you seen the movie? Inception? But
Yeah.
you go in a dream and then dream within a dream and dream with a dream, except that you're
Yeah.
going replacing that with Kubernetes, right?
Yeah, and we are kind of lucky because it is like Kubernetes in Kubernetes, and we didn't go further with another Kubernetes, so it's all.
Only one Kubernetes in Kubernetes.
Yeah, but if you
Okay,
if you if you
I misunderstood. I thought it's going to be multiple layers. This is boring. See you, everybody. We'll figure out something else.
yeah.
So you're watching Crossplane channel. This is Hassan from. I'm not sure whether I'm pronouncing it Hassan.
Yeah.
Anyways, from Upbound, and he's going to tell you all about running Kubernetes in Kubernetes and everything else.
Yeah.
Go.
Okay.
Go.
Maybe I can. Okay, let's calm down with maybe a quick introduction of myself. I'm Hassan Türkan, and I have been working for Upbound for 2 years, and I was mostly focused on the SaaS part of the product and company, and I was mostly busy with the stuff that I will talk about today, which is like hosting control planes or hosting crossplanes as part of Upbound Cloud's offering. I'm living in Turkey. I am I have 2 kids, etc. So that's all about me, and I think we can now get into the business. So first of all, the problem that I needed to solve, or we needed to solve as a company, is like Upbound would like to provide a hosting solution for Crossplane so that people can just log into Upbound Cloud Console and then click a button and get their own control plane dedicated to them and well isolated. But the problem is, to install a Crossplane, you need a Kubernetes cluster. So this is how you usually install a Crossplane. But the problem is we could not spin up a new dedicated Kubernetes cluster for each and every control plane request. And because we are targeting hopefully a very high number of control planes to host a very high number of control planes, we were describing it during the designs as millions of control planes. I hope our company will see those days, so hopefully soon.
You didn't want to you could have created millions of clusters and we would last for 3 days as a company before going bankrupt.
Yeah, definitely. And this was exactly the problem that we had to solve. To solve that problem, we would like to, we focused on the special traits of Crossplane, and would like to understand if we could make some optimizations so that we wouldn't need to run a dedicated and full-fledged Kubernetes cluster for each and every Crossplane control plane. So I would like to share my screen right now.
There we are. There's your screen with many of us.
Okay, so I think it is better now.
It's good.
So this includes a couple of slides actually that I used in another talk. So I would like to just use a subset of them to better describe the problem that we are dealing here, and what makes a Crossplane special in terms of hosting it. So first of all, Crossplane uses Kubernetes as a general purpose control plane. It is not using it as a container orchestration tool, which is actually the thing that makes Kubernetes popular. But also Kubernetes is becoming more and more popular with its control plane and its API, thanks to the great extendability story with custom resource definitions and controllers. So what we mean by using Kubernetes as a general purpose control plane is, instead of managing the resources living inside the Kubernetes cluster, we are talking about managing the resources that are external to the Kubernetes cluster. So Crossplane, as like most of you know, Kubernetes uses Crossplane uses Kubernetes to provision cloud resources. Actually, this doesn't have to be cloud resources. So this could be anything that is external to the Kubernetes itself, or the Kubernetes cluster Crossplane running itself. So you could even write a Crossplane provider that manages your own on-premise infrastructure, on-premise stuff, or you can even like implement a provider that controls your home, like home system that you have built in a custom way. So the key trait of Crossplane that this trait of Crossplane allows us to make some optimizations. So what are those optimizations? So here you see a high-level picture of Kubernetes architecture. And these are the components that we see in a typical Kubernetes cluster. And first question that we asked ourselves is, do we really need to run all of these, or do we need to have all of these to run Crossplane? And the answer is no. Since we don't schedule any in-cluster workload, like pods, deployments, or stateful sets, etc., we wouldn't need a node. So we just deleted the node and the components coming with the nodes. And then since we don't schedule pods, or since we don't schedule ingress controllers or cloud specific stuff, and since there is no node and there are no pods, then we could also ignore kubeproxy and kubedns. And all we need is actually the Kubernetes API server, controller manager, and etcd. And we call this as the control plane of Kubernetes. And even one step further, we could optimize this, which is, the controller manager is actually a set of controllers that are coming with Kubernetes by default. And if you look at which controllers do we have there, for example, attach detach controller, which is dealing with mounting persistent volumes, etc. Since again, we are not managing stuff living inside the cluster, we don't need to deal with attaching and detaching persistent volume claims. So when we look at those controllers one by one, we could again filter most of them out and only leave the ones that we need to use Kubernetes machinery, like service accounts to leverage Kubernetes RBAC, or for isolation Kubernetes namespaces, or when we delete a namespace, we would like it to be garbage collected, etc. So it really boils down to a very limited subset of controllers, and this is actually how we are running controller manager today. So when we look at the picture for our control plane, it looks much better now. We just need to run these components. And actually, one thing that we forgot in this picture is we also need to run Crossplane itself, right? So let's add Crossplane itself into the picture, and also we will also need to do the same for the provider controllers. So we will need to run API server, controller manager, etcd, Crossplane, and the provider controllers. All we need to run is these components. So how do we run those, and how could we scale them up very quickly? first of all, we will put them into the containers for better isolation so that we can host multiple tenants on a single cluster. And then we run them inside a Kubernetes cluster. So this is where the statement of like running Kubernetes inside Kubernetes comes. So we are actually running Kubernetes inside Kubernetes, but it is not actually running full-fledged Kubernetes inside Kubernetes clusters. Rather, we are running Kubernetes control planes inside Kubernetes clusters. So I think this is all I would like to show for now. So maybe we can stop sharing. Yeah, sorry for that inception image that is shown, which actually it is somewhat related to the topic. So I think it is fine. Yeah, basically this was the problem that we needed to solve. And after we like found a solution for that, we had the possibility of provisioning a Kubernetes cluster, but then running multiple control planes on that Kubernetes cluster. So yeah, this is actually the problem definition and how we reach to a solution. So I can continue by showing some real stuff if there are no questions at this point. I cannot hear you. Victor, I think you are muted.
Sorry, yeah, that was my bad. Yes, show us the terminal. Okay. Show us the money.
Okay, great. So maybe you can just show my screen again.
Yep.
So yeah, now I have a local environment for Upbound Cloud. So this is actually what you would see when you go to upbound.io and go to console, register or log in and see the Upbound Cloud console. But instead of like showing on the real production environment, I have a local environment so that I can, break and show things in more details. So this is what you get as a cloud console. And what I am talking about in terms of, creating control planes or provisioning hosted cross planes is actually what happens when we hit this create new control plane button. So when you hit that, you have two options today, hosted or self-hosted. So you could select the self-hosted option and you can just install Crossplane on your Kubernetes cluster of choice and then easily connect it to the Upbound Cloud Console so that you can still leverage the features or the things that are provided by Upbound Cloud Console. But today our focus is the hosted one. So let's say demo. And before hitting this create control plane button, I would like to show you my terminal. And this terminal points to the Kubernetes cluster, actually the hosting Kubernetes cluster that will host the control plane that we will provision soon. So
I'll stop you there for a moment. Press Control Plus a couple of times while you're in terminal.
What's that? Control Plus.
Control Plus. At least Command Plus is on Mac. I'm not sure whether you're using Mac. Yeah, Mac. Command Plus. Make it bigger. There you go. Brilliant. Okay. That's absolutely brilliant. Yes.
Great. Okay.
Thank you.
Sure. Yeah. So right now on this Kubernetes cluster, we have one control plane provided that I just made ready to test stuff and also to make sure that if something goes wrong, I can just use that one to show more. But basically, now I will hit the now I will hit the create control button and we will see what's happening on the other side. So I hit that and you see creating new control plane. And here you see that a new Crossplane cluster custom resource, since we are a Kubernetes company dealing with operators and controllers, these things are also implemented as custom resource definitions. So we extended again this Kubernetes cluster to provision custom resources named Crossplane cluster. So you can see different phases. It deployed the tenant Kubernetes, deployed the host components, tenant components, and now waiting for components to be ready. And on the same cluster, let's see what we have in terms of is control plane. So here you can see about a minute ago, 2 new namespaces came up. One is system namespace, one is controllers namespace. And the system namespace is actually, or maybe even better, I should just switch to that one and show you what we have there. Okay, so these are the stuff that were provisioned for my control plane on this shared Kubernetes cluster. And here you can see a couple of pods, and the ones starting with tenant Kubernetes actually responsible for providing a Kubernetes control plane that could be used as a general purpose control plane. Here you see API server. Here you see controller manager. And one difference actually than the presentation that I showed in the beginning is actually even Crossplane do not manage in-cluster resources. Crossplane still needs to deploy pods, and they are actually provider controllers. And to be able to deploy provider controllers, we will still need to be able to deploy actual pod workloads. And for this purpose, we have implemented a virtual kubelet, a custom virtual kubelet version or extension. And what this kubelet does is actually watching the the tenant API servers, and when there are some pods or deployments created, actually pods, not deployments, when there are some pods created, this kubelet is actually reflecting that pod to the host cluster in a well-defined and isolated fashion. So remember, we also have another namespace for this, for this control plane, which is controllers. And if we switch to that, or no need to switch, maybe just show it. Yeah, right now there is no pods because we didn't install any controllers yet. So here, I came back to my Upbound Cloud Console. You see that my control plane is ready, and it is a hosted one. And sorry for that. And when I get into that, I have the ability to browse the Upbound registry and select some providers and install them. The thing is, since this is a local environment, I didn't push any providers into my local registry, so I didn't see anything to install directly from here. But if I did the same thing from our production console, we will see, for example, provider AWS, and this would allow us to deploy directly from the UI. So since this talk is not about those features, I'm not getting into details in terms of that. But what I can do is I can connect to this tenant API server and see what we have inside that. To achieve that, I have a debugging Helm chart. and this debugging Helm chart actually deploys this pod. And now I can get into that. CTL, get back. Yeah. So here, now I am inside the Kubernetes cluster, which is the one that we are using as a control plane. So here you can see we have like completely different cluster view than the actual cluster. So on the actual cluster, like we have other namespaces, but here we have a completely different view, and our Crossplane controllers are actually watching this tenant Kubernetes. So now the last thing that I would like to show you is maybe I can Kubernetes CC. So here we don't have any controller installed yet. First of all, I will need to deploy the Crossplane CLI. And now I can, for example, deploy the provider GCP. So when I deploy provider GCP inside this tenant Crossplane, you can see that the actual controller pod is scheduled and running on the host cluster. So yeah, I'm not sure anything else that I would like to show at this point. Yeah, actually, if I get back to my console view, I see that provider GCP is actually being installed, and I can see that provider GCP resources are appearing here. Yeah, actually, that's all in terms of demonstrating what we have regarding provisioning control planes with Upbound Cloud.
How would you compare it with something like vCluster? Is it a similar solution, different?
Yeah, that's a good question. Actually, yeah. So I recently learned about vCluster, and thank you for that, Victor. I heard from you about that, and I just gave it a try. It's really a cool project, but there are a couple of key differences than the approach that we are using here, which makes more sense for our SaaS solution. By the way, can I switch to your view if you stop sharing? So
to my view.
Okay, so you already stopped sharing.
Yeah,
right? Okay.
I read your mind, man.
Okay, that's great. I'm learning how to work with you. So yeah, yeah, basically vCluster provides very similar functionality, but remember the optimizations that we made here, which is running Crossplane, which is actually does not require a full-fledged Kubernetes cluster, comes as back to as optimizations. But in vCluster case, they cannot make such assumptions, and they are targeting to be like full-fledged, like at least to behave as full-fledged Kubernetes clusters. And this in turn prevents them, I believe, to make the optimizations that we could do here. And another difference is we have built everything as like Kubernetes controllers, so that we can orchestrate, manage, and take backups, etc., by building on top of those. So the resource Crossplane cluster custom resource, the one that I just showed you, is actually managed by an upper level controller which is actually triggered from the control, like create control button from UI. So this allows us to automate, again, using the Kubernetes API. In vCluster case, I remember that they have a CLI, and you could use that CLI to deploy new tenants. And that CLI is actually creating new stateful sets, new namespaces, etc. So of course, this could be achieved by implementing a controller on top of those, etc. And another thing, maybe one last thing is, like building our own solution provides us more flexibility. In vCluster case, each tenant has a dedicated namespace, so one namespace per tenant. In our case, you just saw that we are actually creating two namespaces per tenant, one for system, the other for controllers. This is for better isolation, because controllers are the things that could be implemented by third-party developers or by others, and we need more isolation in the controller's namespace with network policies, RBACs, like pod security policies, etc. So I didn't went into much details in terms of how we secure our tenants and how we could have a multi-tenant solution so that we are isolating different tenants, etc. But in short, building our own solution allows us much more flexibility to achieve such sort of implementations and optimizations.
Yeah, I mean, that's kind of the always similar story, right? When you build your own, then you can optimize for one use case, while if you take something off the shelf, then that needs to be made to serve many purposes, right?
Yeah, definitely.
So if I connect to, let's say, Abound Cloud right now, I'm basically effectively not connecting to I'm connecting to the ingress inside of the pod that acts as or a container that acts as a control plane, my control plane, right?
Yeah,
something
you can.
Like that.
Actually,
when you do kubectl against Abound Cloud, I'm effectively going inside of that container. Is that correct?
Yeah, that's true. Actually, if I could quickly, if you could quickly share my screen.
Yep.
So when you go to your control plane, here you can see a connect using CLI option, which gives you a couple of steps. And when you follow these steps and then run kubectl commands, actually those commands are running against that tenant API server that I just demonstrated. You are muted.
I don't know, what's something wrong with my mic. Anyways, we'll give Fox then. I'm going to count to 5 if somebody has a question, and if there are no questions, we can close the stream. Does that sound like a plan?
Yeah.
You didn't have anything else, right? Okay. 5, 4, 3. Type faster. 4, 3, 2, 1. Go. Thank you so much for watching. Hassan, this was amazing. See you, everybody, next week.
Okay. Thank you.
Cheers.